Welcome to Main Street Minds with your host, Amish Munshi. This is where industry leaders and seasoned pros share their secrets to success beyond limits. Let's dive in.
Hello and welcome to Main Street Minds. Today we have a very special guest, Surya, who has done his engineering from IIT and has worked in the industry for many decades and now is an investor. So he has seen it all, I would say. And he's working on some very innovative new technologies. And without any further delay, let me open up the floor. Surya, can you introduce yourself?
Sure. So I am basically, like you already said, I am graduated out of IIT Madras way back in '98, and then came here for my master's. And then, of course, I worked in the industry for quite some time. Also subsequently got married, after here, when my wife is a physician and I have two kids. But then I kind of also started my own company around 2015 timeframe. Before that, I was working for several years as safety and security embedded systems engineer, for avionics and defense applications. And I kind of had an idea that maybe I can do better than some of the self-driving technologies that are kind of the problem. And I started this company to kind of champion, automation technology for automated electric vehicles, but it's going to use exclusive lanes, as opposed to mixed traffic scenarios that are being tackled. We want to kind of achieve high reliability and high safety, but at the same time high speed automation. So what I call as HART, high speed electric automated road transport. That's the future of 21st century road transportation is how I look at it. So I started this company and then kind of incubated through IIT Madras Incubation Cell. We also got a little bit of funding, and I could kind of build up a team. But then in the meantime, when I got some awards, when I went to China, where they kind of gave some awards as well, for the core technology. But that's when COVID hit, so I had to kind of ramp it down a little bit, because, first off, it was transportation and it needed much higher investment. So I was not able to gather sufficient investment actually to kind of take it forward. But I got some patents and all that, issued as well. But then I'm also started consulting, because I'm an embedded engineer, I've been consulting with several companies along the way, doing some contract work and other things. But yeah, I'm still going along, I also invest in companies, especially that kind of, meet my fancy, especially ones in transportation or wireless and other domains, that I'm passionate about.
Yeah. And where do you see the maximum potential of this? Is it going to be in consumer cars or is it going to be on commercial vehicles?
Actually, I would say that, if there's sufficient privatization of roads or kind of bring in market forces to kind of, actually build these lanes for automated vehicles, I would say it is on multiple fronts, much like telecom carriers, or wireless carriers that came up after spectrum auctions. I would say, there will be road operators, that kind of operate the road, private operators for profit, that will actually operate these lanes for automated electric vehicles, high-speed ones, so that you have some, improvement in service quality and service than what is currently offered by roads today.
So,
very, ad hoc.
Yeah, and how do you bring about a change this big? How do you go from the piece of the technology itself is challenging, and then how do you go ahead making changes in the world, setting up the lanes, and who will be your ideal customer? Will it be a car company? Will it be somebody that's just going to set up the full infrastructure?
It is actually on both fronts. Imagine, for example, a cell phone. There's a base station component that kind of goes inside the network, and then there's a modem component that goes inside it at the base level, apart from all the smart other things. So that's the same way, there are some components that go on the road, on the infrastructure side, but there's also an onboard technology that we kind of build, that kind of interoperates with this technology on the road. So, but ideally, the road operator should have an incentive to kind of install our technology that we're kind of building to kind of, reap higher and higher profits and kind of improve better quality of service. Today, roads are kind of, monopolistic government operated.
Yeah.
So if there is sufficient privatization, for example, there are express lanes, for example. In the Bay Area, I'm pretty sure you're aware of the express lane. They're charging a hell lot of money, but there is no clear motivation to kind of see how will you improve the speeds and capacities of the lane to kind of provide better quality of service or any guarantees of service, like for example, like So, but if the lane is kind of automated with our technology, for example, we can kind of have vehicles move in a platoon fashion, like at close distances, and kind of move at higher speeds, and also with some guarantees, so service guarantees, like in terms of how fast they will, what the travel time would be from point A to point B, for example, on those lanes.
Yeah.
So that's the vision that we have. Like, but then again, like market forces have to play in place. That means the policy changes have to happen. When of course, like the debt is a big thing today. The government wants to reduce debt, and that's one good way of reducing debt.
Yeah.
You auction the planes for a private operator to actually operate them. You make money. The government gets to kind of make money by actually.
Yeah, makes sense. So tell us a little bit about like how did you what was the journey from IIT from masters, like how did you manage to reach where you are today?
Sure. Yeah, I mean, after, like I said, like in '98, I finished my BTech from IIT Madras in electrical in communication engineering, like electronics and communications. And then I did my master's from Clemson, South Carolina, again, like in DSP and communications. I did my master's in 2000. And initially, like I was working with several semiconductor companies, particularly national semiconductor connection systems, working on cable modems and wireless, actually, like for Wi-Fi, because of my communication background, like Wi-Fi, and also cellular chipsets like dual mode, GSM and CDMA chipsets, basically for baseband cellular chipset for phones. Right? And then I worked on several other companies like Siemens and other things, but I also got married to my wife, like this physician. So I moved around the country quite a bit, like because she was yet to find her residency at that point of time when we got married. But then finally she found it actually in New York. So we had to move to New York, though we started off in San Diego, moved back to New York. In the meantime, I went to Hawaii for consulting gigs, Florida, but then went to New York. And then she finished her residency and we wanted to move back to California. That's when we got a green card and everything. And so we moved back to California in 2007.
Okay.
And I've been in California, and I started working for Wind River in Alameda. Like actually, like that is a operating system software company, like much like Windows or other things, but it's for safety critical and security critical operating systems, like like real time operating systems. Like, a lot of airplanes and avionics applications, as well as several automotive manufacturers. They all use that different operating system like software. I was developing that operating system software, and that's when I kind of had a good grasp of safety and security functionality of operating system and real-time needs and requirements. And I was observing what's going on in this, the self-driving domain. So then I thought, like, maybe it's time to kind of see if we can kind of actually make better use of the vehicles as well as the road. See, today Tesla vehicles can do 120 miles, 140 miles an hour, or any car can do 120 miles an hour if you give the road for itself. The challenge is, do you move them together all in sync, like on the road, like at scale? So that's the kind of technology that I had, the vision I had, like, and then I started digging in and kind of developed a core concept as to how that can be done using some of the radar and technologies that are kind of inspired from guided missiles, like kind of came from guided missiles. The homing guidance, like But then it's applied quite a bit in automotive. But how do you build a guidance system to kind of make sure that you actually keep it in the lane with much higher reliability than the camera-based, like, for example. So I kind of developed patents, and then I, teaching a lot of investors, and I also kind of got incubated by IIT Madras in India, because they showed a lot of interest, because I come from there, like. So I went back to India, kind of built up a team there, when I was funding it out of my own pocket. So it was, but then they also put in a little bit of money. And we made a lot of progress in terms of simulations and other things, like. But we needed substantially more money from the investors, which was not coming by because investors were still, hanging along with the self-driving cars and other things, like. So this was a little bit of a tough sell. Though China showed quite a bit of interest, I would say, like for all that it matters, but at that time, like right after my China visit, COVID hit. So I had to take a break out of that, like, and I was running out of money and patience as well by that time, like, so I had to take a break. Like, so So I kind of had to ramp it down a little bit and then start consulting. That's where
Yeah.
I am right now. I'm still doing consulting gig, but I'm also open for
Mhm.
avenues to kind of take this forward.
Yeah. So when did you decide to like say you need to venture by yourself? Like a lot of like being a career channel, I'm trying to like see like when does a person decide saying should I join a force with some existing company that is doing something similar that is of interest versus saying, hey, I'm just going to do this by myself because no one else is doing it.
Yeah, that was in around 2015 time frame. Like that's when I kind of, you know, I always had this idea that maybe, I want to do something on my own, but I also wanted to do something that really solves a pressing problem.
Mm-hmm.
And traffic congestion, like I said, like I moved around the country, all around the world. Everywhere traffic congestion is a big problem, and road safety is a big problem. Like every day it's almost like normal. Like somebody gets killed or some accident happens on the Bay Area highways. People kind of forget, like, and then there's an accident there. Like then kind
Yeah.
of move on. But it need not be like that. Like so because I kind of also studied several well-functioning systems, like Shinkansen in Japan, for example, like
Mm-hmm.
how they were innovated, stories about them. So that all that kind of motivated me to kind of do something that is going to solve a pressing problem.
Mm-hmm.
Then start a company, but at the same time, like I wanted to do something on my own, and it was not. To do something along with what everybody else was doing, like. I would be just doing the same thing like the others are doing. Like, there are a lot of companies that are doing self-driving cars today. But
Yeah.
ultimately, I didn't believe in the idea. Because, it's not the question of just removing the driver. It's about, what kind of improvement in quality of service you can kind of bring. Like, because transportation has to
Mm-hmm.
not just be about removing the driver, but it has to kind of, reduce travel times, increase the comfort, increase capacities, the road capacity, road utilization. A lot of other factors kind of come in. It's multi-criteria optimized problem. So that's when I kind of said, like, okay, let me give it a try with my ideas, because it was, I could dream up this idea, like, basically, like, that you can, the technology was there, like, that, I could envision it, like, because, I know how missiles work or other things work because of my background, or how wireless technologies work. So, I thought, like, let me patent this and see how far I can take it.
Mm-hmm.
So I still believe in the idea, like, because, somebody has to redefine the 21st century road transport. And
Yeah.
so why not it be me? Like, Tesla did to some extent, but that's
Yeah.
not the end game. Like I would say, like,
Yeah.
there's a lot more to go. Yeah.
Yeah, and going from like being in the tech or maybe even a leadership role within the tech industry to having your own venture, like how does somebody manage to like succeed in doing something like that? Like like as an example, like somebody has to be open to like learning everything, right? Managing your finances, raising capital, taking care of the technology implementation, looking at the competitors. Like if somebody wants to, like, let's say they have an innovative idea and they want to launch, what are some of the recommendations that you can give them?
Be clear about your purpose first, like, basically, like,
Mm-hmm.
why you want to do this. There are a lot of people, like, who want to do it just to kind of, build a company or get rich, for example. That is okay, fair enough, like, actually, but then your pursuit has to be a little different, like, as to how
Mm-hmm.
you do. Because my pursuit was not just about making money; it was about also solving a problem that was a big pressing pain point, like, for me
Mm-hmm.
all along, like, that I believe, like, is a pain point for everybody else. Like, whether nobody is showing the courage to kind of tackle it, probably, like, is how there's no right or wrong in this. Like, I'm not saying that. Ultimately, I also have to make money.
Right.
But I did made this decision when in 2015, because by the time, to some extent, my financial position was a lot more stable or better, because my wife is a physician, like I said,
Mm-hmm.
and I had enough savings by that time. Like, I was working already by that time for about 15 more than 15 years. Like, so we had
Mm-hmm.
sufficient savings to kind of at least not be having difficulty putting food on the table. That's
Mm-hmm.
very important. Ultimately, like, for an entrepreneur, how much ever you think like that, you can kind of, maybe you'll get the very first investor right up front, like, but you never know when you'll get the investor in, like, or kind of, or be able to kind of get the business pay for itself.
Mm-hmm.
That's the other thing, like, those are the big constraints. Be clear about your purpose, and can you sustain yourself, like, in a
Yeah.
kind of doing what you want to do without depending on, can you afford to fail, like essentially? That's the big. You cannot go with the mindset like that. You will definitely be successful. Yeah, ideally, you want to be successful, but you also have to be ready to accept failure at times, because or it can take a delayed success. You never know when the success. So those are the main things that somebody has.
Yeah, makes sense. Yeah. So right now, like, what are some of the skill set that somebody, if they want to like learn the exact technologies that you're working on right now, what are some of the skill sets do they need? You did mention one of them was like digital signal processing. Is that still the core technology?
Yeah, I mean, at an embedded level, like particularly, I mean, have good electrical engineering was how I kind of. And a lot of people are only into computer science these days, but having a good understanding right from the hardware level is also very important. But of course, like, I mean, I'm an embedded software guy still, like, but understanding interfaces and all this, like importance of interfaces or rigor in the interfaces and all these things kind of come from particularly electrical engineering background. This is very important for what kind of work that I do. Like, of course, there are several other companies that are very successful, pure software companies and other things. But for me, like, I would say, like, having good embedded systems background and also wireless communications, wireless technologies, background in actually understanding some of the nitty-gritty details of the hardware, which kind of comes from actually hands-on work as well. Right? So those are things that are very important. Be ready to kind of do some hands-on work and not just get stuck on the theory.
Yeah.
But at the same time, theory is very important as well. Like because a lot of things would never get solved like if you did not understand the theory well. Like you can kind of keep tinkering, but both have to go hand in hand.
Yeah. So at what stage is it right now? Like, like if you have like a stretch of road, like, do you have like a prototype that we can actually like drive?
Yeah, I mean, we have prototypes and we did some of the technologies as far as the radar sensing goes and, how we kind of want to install these. But again, like it has to go in stages, but it needs funding. Like definitely, like, I mean, it doesn't happen in one night, right?
Oh, yeah.
You need funding, somebody with sufficiently deep pocket to believe in the idea who kind of puts in like to do multiple iterations to kind of take it forward and kind of show. Much like how cell phone developed, like cell phone didn't start off like iPhone, like it started off with like a big size phone, like for example.
Yeah.
But then it kind of shrunk like that by the time it kind of came out. So this is a maturity level that where we are kind of now. But we have a good understanding of how it can be done, like or how we envision it at least, So we have a way to kind of take it forward, but obviously, like I'm working very hard, like with trying to kind of bring the industry partners, working with standards bodies, particularly in TSI in India, like kind of championing this effort, like essentially, like to kind of automate the roads, like basically. So that's the kind of maturity level that the technology is at right now. Like, but it's not something that can be productized right away or kind of have a product delivered to market.
Yeah. Like, and then like where, obviously you mentioned like the standardization and having a set of rules is really important. But where do you see, like how, like let's say everything goes well, right? Like there is enough money available, investment available. Like let's assume a theoretical world of like everything actually supporting everything that's going on. How long do you think an implementation might take? Like, will it be a few decades or?
No, actually, 3 to 5 years is how I would put it as like, if we have enough money and enough partnerships and everything in place, 3 to 5 years, we should be able to kind of at least automate, let's say, like the Bay Area freeway, like basically like from, one of the express lanes can be automated, for example, with the core tech that we are building. 3 to 5 years is a substantially sufficient because the way we design it is way different from how trains are designed, for example, like because we will be kind of designing it for reconfigurability, upgradability. These are things that I kind of studied very carefully, so that you're not stuck with one thing if it's not fully functioning or kind of you can kind of upgrade it, and take it forward, obviously, but you can kind of get it into operation within 3 to 5 years.
Yeah, and like, are you seeing more the initial adoption being more on the metropolitan regions, like urban areas? Or do you see like longer stretches of roads on the like highways?
Ideally, like we want to show its effectiveness to where it's most needed. For example, ideally, like there is a lot of congestion on while there's a huge need for transportation, you kind of get stuck in congestion every day in the morning. But if you can kind of show that you can do a 20-mile stretch every day without a problem in 20 minutes start, for example. 20-mile stretch, 20 minutes is a substantial improvement. Like every day, without fail, like you will drop the person in 20 minutes, like from point A to point B. That's a substantial improvement, right? So if you can kind of show that, it will scale by itself from there, And of course, like our vision is that we can actually automate the whole country, for example. Compatible with rail, for example.
Yeah, and a lot of people don't quite understand just why this is there is a lot of interest in doing a lot of this automated driving and getting this systemized and successful, but because a lot of people don't understand the implications of this, right? As an example, like I used to live in Berkeley and work in San Jose, and it was just impossible. Instead of driving a car, I decided to start driving a motorcycle. Like it was just crazy. Like, obviously, I was willing to put my life at risk just to go to work. So that, it's like.
And the funny part is there are multiple lanes still. Like there are tens of lanes on each side, but they're all congested. Like the way they're designed, and lane separation is not well thought out. Like even if you give one lane, like I say, like I can push a lot more vehicles. I mean, to just give an example, if you have the 4 lanes moving at 15 miles an hour with certain spacing between the vehicles, and if you can make them all move at 60 miles an hour on one lane at close to the same kind of a inter-vehicle spacing on an average, you can get the same throughput. Actually.
Yeah.
So it's much, but how will you make it is the technology that we are kind of doing.
Yeah, the implications, I think this is a much needed thing, right? Like we really need to figure this out, and the implications to life, the implications to what people are able to do, the implications to society is only going to be better with this. Yeah, I don't see a lot of downside. It's going to be it's only going to be better than where we are. I don't see things. I don't think every technology generally has something good, something not so good. But this is something that I just think will only improve people's lives.
Yep.
Yeah.
Yep. That's I'm dead sure about that. How that's why I'm championing it. I mean, at worst, what will happen? I may not be able to realize it, but somebody else may be realizing it. But still, somebody has to champion it.
Yeah.
That's how I look at it and kind of jump in.
Yeah. So, what are some of the career advice that you can give to somebody entering the industry right now? Like, how should they approach their career? Like, look, if they want a long-term successful career in tech, what are some of the secrets?
Yeah, I mean, I started off as a passionate engineer, basically because I always wanted to be an engineer. Even though my dad is also an engineer, he wanted me to be a doctor actually, but I wanted to be an engineer because of course, I was good at math and physics like anybody else, going to IIT. But I also had that passion that right from it captured my fascination at a very young age. I can solve a lot of problems as an engineer, everything is built by engineers, how I look at it. Even television, to telephone to the roads are also built by engineers actually. So I looked at it, and having that passion, initially, it was straightforward. Even of course, after getting into the industry, you learn a lot of things, but ultimately, you need to have a passion to solve problems that impact people. I would look at it. Other skills, obviously with good education and going to a good school, there are a lot of very good universities, particularly in the US. There are several universities, even in UP, I've seen with very good curriculum and very good professors. So you can learn a lot. And of course, on the industry, once you're in there, there'll be a lot more scope to kind of build up your career. The people kind of venture out into other things, but for me, like I said, I'm a hardcore engineer at heart, but I still want to champion some big things which need some business skills and other things as well, which I'm okay to kind of build as much as I can and kind of also share, because I'm also doing a Watson CTO program right now actually, which is kind of getting completed in a couple of days. So there's a scope to kind of learn other skills as well, but you want to kind of define your own passion like this.
Yeah, that's one of the most important things. Thanks for sharing that. So, in addition to that, like, what technologies are you seeing coming into the market right now? Obviously, the self-driving vehicles is obviously one of them, but what are some of the other tools and technologies that you are seeing becoming mainstream right now in the tech industry?
Yes, I mean there are a lot of hardware innovations like GPUs. Like, I mean, actually they became mainstream. Like, of course, like AI is one thing or AGI is one thing, but apart from that, like there's a lot of compute power. I would say, like, that's
Mm-hmm.
possible. Like, or for any other application as well. Like, including whether you kind of want to automate things, like, you want to kind of have a very good graphical user interface, like, in your vehicle. You still need to use the same kind of hardware, like CPU.
Mm-hmm.
Like, whether it's AGI or not is immaterial for me.
Yeah.
Whether you kind of can beat humans or not is not what I. So that, in that way, like there's a lot of technology that's readily available, but how will you kind of integrate them to kind of meet the performance objectives and safety requirements and kind of provide a solution that really meets people's needs is where I would say like there's a lot of scope for innovation like this.
Mm-hmm.
As far as technology pieces are concerned, like, I mean, like the compute power or even sensing technologies like radar, there's a lidar, of course, like, but radar can do a lot of things that is underutilized right now. Like, in the same way, like the car, I mean, electric vehicle is underutilized actually. Like,
Mm-hmm.
I mean, the capabilities are much more. So in
Yeah.
that way, like, I would say like there's probably a need to kind of think about how best to make use. That's what actually happened even with DeepSeek, right? Like, for example, you heard about, probably, I'm pretty sure, like all that's going on with DeepSeek versus
Yeah.
OpenAI, like, because DeepSeek kind of made use of the existing hardware a lot more optimally. Because as an embedded engineer, I can definitely see that, like, what they would have done, like this.
Yeah.
Because that's one of the things that I've always been doing all my life, basically, like how to make better use of it at the lowest level.
Yeah.
So that is the kind of skill set that is needed, like right now, like as to how to optimize on the existing technologies to kind of build a better solution that meets people's needs at a more fundamental level.
Mm-hmm. Makes sense. Yeah. Yeah. So, in addition to like the hard skills, like the actual technologies, and you did mention like for somebody to succeed in the long run, like they should have a mindset of focusing on being a solution provider, right? So, any other recommendations from the mindset perspective to succeed in our industry?
I mean, be ready for failures. Like, you learn from failures, but you build on successes as well. Like,
Mm-hmm.
but I mean, especially like failure should not deter you. At the same time, success. I mean, you should be ready to build on your success as well. Like, I would say, like, success shouldn't get into your head, like, but success should get into your head as well to some extent. Like, because,
Yeah.
I mean, if you're successful, you have to build on that. Failure should not deter you, and learn from it, move on.
Yeah.
But at the same time, success should also be
Mm-hmm.
taken forward like this.
Yeah.
That's how you have that kind of an attitude, and that kind of comes with purpose. If your purpose is clear,
Mm-hmm.
you know where you're going,
Yeah.
what you want to do, then that automatically comes. Like, you
Okay.
know what failure and what the success, but at the same time, some people think too much about rocket science, but rocket science is not that complicated. It's kind
Yeah.
of like
Yeah.
you fail, like, but still, like, your mission is something that you kind of set your eyes on and kind of want to move along. Like, right? So
Yeah.
that's
Yeah.
like that, like, actually.
Exactly.
So,
Makes sense. Yeah. So, and if somebody wants to reach out to you, like what's the best way they should be reaching out to you?
of course, I'm on LinkedIn, pretty active on LinkedIn, and I'm also, I mean, if somebody kind of pings me on LinkedIn, I'm pretty sure.
Okay. Yeah,
I kind of
that's
take request and also kind of share my email.
yeah, makes sense. And then just before we conclude, like any other recommendations or final tips that you want to share with the audience or about yourself?
Uh, yeah, I mean, I have, like I said, like I have two kids, and my son is going to college pretty shortly. Like, basically, he got admissions in a few of them. Like, he's trying to decide, but he's right about getting admitted to college for the first time.
Congratulations.
So I'm very excited for him, like, actually, because I still remember my days, like, when I kind of got admitted. Big thing for us
Yeah.
back
Yeah.
in India. So I'm very excited to kind of take him on college visits and all that.
Yeah. I
That's
hope
what
he's able to stay local.
Yeah, and I would say like enjoy time with your families as well. Like and career is great. Like but again, like more important is you kind of even if you're an engineer or a techie, like you're building technology for people, and that kind of comes from having an appreciation for people around you and family and everything. So yeah, that's how I would put it.
Yeah, that is such a big thing that you did mention. Like, yes, on one side, yes, you have to build on success, be ready for failures, build on the success, and all of that is great within the career. But then also, like, within the career, if you're developing something that it makes an impact on people's life, and then personally on a personal level, focusing on saying, hey, everyone around you is honestly the most important part of your life. So like it's a beautiful way, like you
Build a better world for the future. Like actually, yeah, sure, for the kids. Yeah.
yeah, sounds great. So thanks for coming on the show today. I'll include your LinkedIn description, like the URL in the description below. Feel free to like reach out to Surya and get introduced. I think there's a wealth of knowledge that is awaiting, and he's always open to like speaking with you. Thanks.
Thank you, Amish. I mean, it's been a pleasure. Like, thank you.
Thank you.
That's a wrap on today's episode of Main Street Minds. Want to share your journey with our audience? Head over to mainstreetmindspodcast.com/guest to apply.